on this part of chemistry, we are going to talk about periodic table. And we are going to talk about also the story of chemistry shortly, and how the periodic table was improved till the beginning, till it became to the way that we see it now. Okay, as we know, people thousands of years ago used to use some elements like iron, gold, silver, and other elements, but nobody at that time started or tried to know what are the components of these elements. So for example, iron, what are the components of iron, or what is inside it? Till the date that was about 400 years BC. 400 years BC, that means it's about 2,400 years ago from now. A philosopher, his name is Democritus. So Democritus is a philosopher, is a Greek philosopher. 400 BC, that means about 2,400 years ago. He suggested something. He proposed that logical idea. What he proposed? He said, any object, if we have an object here, if we divide this object, if we keep dividing this object, at the end, we're gonna reach a part that is uncuttable, that is indivisible. And from the word here, uncuttable or indivisible by the way, indivisible. In Greek language, it is atomos, which is what? A word that is what? Atom. That is a word what? Atom. So atom mainly came from a Greek philosopher or idea that it means indivisible part or indivisible. This idea was logical, by the way, but did people believe what he said at that time? Of course, no. Okay, what people used to say then? What people used to say then? Another philosopher, his name is Aristotle, by the way. What he said, he was an influential philosopher at that time. He said what Democritus said was not right, Then he suggested another idea. He said, no, matter is composed of fire, water, air, and earth. This is what he suggested. This is what he proposed. That any matter around us, chairs, walls, bricks, anything we see it in our lives, mainly it is made of fire, water, air, and earth. And people at that time believed who? Did they believe what the logical person said or what this philosopher said? Of course, they believed the more influential person. His name is what? Aristotle, by the way. And they believed what he said, and they believed in this theory, by the way, that matter is composed of fire, water, air, earth for about 2,000 years. And they believed in this idea. And they forgot what Democritus said. They forgot what he said. Then they believed in this idea, or in this in this proposal. Okay, what happens then? 2,000 years later, then what happens? A person came, his name is Dalton. His name is what? Dalton. And Dalton was a great thinker at that time. He proved scientifically by experiments what this philosopher said. And he said, Democritus was right. When he said that, 2,000 years later. You believe it? About 2,000 years or 2,200 years later, he believed. Then he said, that means now it's related to life, so that not everything you tell your friends or you advise people, they're going to believe you, that since you are logical. No, sometimes they discover later that you are right. So around 2,200 years later, Dalton proved that Democritus was right. Then Dalton gave a theory, and this theory was by experiments. That means it was scientifically experienced and proved. What he said? He said same element has the same atoms. Same element has the same atoms. So that means each element has the same the same atoms. This is the first point. Then he said different elements have different atoms. Different elements has different atoms. And he said also compounds like water, for example, is composed of atoms but in fixed ratio. So for compounds, he said their components are in fixed in fixed ratios. Mainly he said this one, and he said also mainly that atom is the smallest element, the smallest part of the element that retains its properties. So Dalton theory, by the way, it was the groundbreak for chemistry. That means it was the base that chemistry then started from. These ideas now, they still alive till now, and they are proved that it's right. Just in some ideas that he said smallest particle, and then they discovered later then there is still protons and electrons are smaller than atom and also the nucleus. So what he said, Dalton here now, it was really an authoritative idea at that time, and he proved it scientifically. Okay, then what came later? What came later, a person, his name is Thomson. Okay, what Thomson said? Thomson, he discovered the electron. He discovered the electron. And when he discovered the electron, that means he talked about what is inside the atom. So Dalton now, he just talked about the atom. So Thomson started now to understand what is inside the atom. And his model is called plum pudding model. It's like watermelon. It's like a dessert, by the way, but it's like watermelon. If you cut the watermelon, by the way, you're gonna see the whole part is green, is red, and this red represents the positive charge, based on what Thomson said. And the black seeds, they represent the electrons. So that means this one, what Thomson suggested. So he discovered the electron, but his model was not right completely, because he said most of the atom is positive charge and the negative charges are distributed inside it. Like exactly the watermelon, how the red is like positive charge and these black seeds are the electrons. Okay, then what came later? Okay, till now, as you see, we are talking about the atom. We are talking about mainly the atom, which is the component or what is the main part of the element. Okay, then also in that age, which is in the 18th century, a scientist, his name is Mendeleev. Okay, this one now, what he did, Mendeleev he said, okay, why don't we take these elements that we already know them and we put them in a table? We order them in a table. This is what he did. He suggested the elements that they already knew them at that time. Why don't we put them on a table? Okay, good idea. We put them on a table. Based on what we order them, Mendeleev said we order these ones on a table based on atomic mass. Based on atomic mass. Okay, thank you. What comes next? Okay, at that time, later in the years, a person came, his name is what? Mosley. And Mosley here, now what he said just an idea. He gave an idea. He said, to order these elements on the table based on atomic mass is not logical. Why don't we order them based on atomic number? Based on atomic what? Number. Then the table was changed. The table of elements was changed in the order of elements based on atomic number, not atomic mass. And this is the main idea of the modern periodic table that we see it now, that we study it now in chemistry. This one here, its main idea of ordering elements based on atomic number came from what? From Mosley. Okay, what comes next then? What comes next? And you have questions based on these ideas. Okay, who came next is a great scientist. His name is Rutherford. Okay, what he said. Rutherford, what he did. Rutherford is the scientist who discovered the nucleus inside the atom. And also, based on that, he is the person who discovered protons. So you understand, Thomson discovered the electrons. Okay, then from here, as you see, these ones now, Thomson, Dalton, Aristotle, they are talking about the atom, and also Rutherford. But Mendeleev and Mosley, they are talking about what? Ordering of elements of the periodic table. Okay, Rutherford, how he discovered the nucleus. He made just an experiment. He put here a thin gold foil, and he fired alpha radiation into that foil. Then he put here fluorescent screen. He said that most of the radiation moved through the foil into the screen. So he said that most of the space of the atom is empty. This is number one. This is what he said, Rutherford, based on his experiment. And he found that some of the radiation was deflected. Okay, and alpha particles, as we know, is positive. So that means, he said, this portion of radiation that it was deflected to other sides, and some of them was bounced back to the source. So he said, this small part that it was deflected and bounced back, this one is as a reflection of a dense, a small particle inside the atom. Then it was called what? The nucleus. So he proved that there is a small, dense, positive part inside the atom. Then it was called what? Nucleus. And this was based on his experiment. So he explained that there is a small, dense part in the atom, and he said this part is positive. That means positive, that means related to protons that are inside it. And he, by this experiment, he proved what Dalton said and what Democritus suggested. And he just proved that one idea of Thomson was not right. Thomson discovered the electrons, and he said, like the watermelon we said, but Rutherford now explained that the positive part is not for most of the atom. It was just a small part of the atom, and this atom size, regardless or compared to the whole size of the atom, it is very small. So that means the small part, which is positive compared to the part to the volume or of the atom, it is very small, and that is unlike what Thomson said. So then, based on that, another scientist came who discovered then the neutrons. His name is Chadwick. So this is now the short story how chemistry improved. Okay, Rutherford, by the way, it was like about 100 years ago. It was like 1911, like this. That means about 100 years ago. And it was like the idea of many advances came later based on Rutherford. theory, like Bohr, which is related to the orbitals and around and the shells and the ordering of these energy levels then came later based on Rutherford idea. So that means the ideas or the new chemistry mainly was based then on Rutherford experiments. So this one now is the ideas or the short story of chemistry. I hope you understand it and just you notice the main ideas of these scientists, what they discovered. Okay, what was the result now of all the discoveries or all these accumulative discoveries? It was what the new periodic table that we know it. Okay, what is the new periodic table that we use it now? Okay, this one now, as we see, this is the periodic table. This is the new periodic table that it was a result of thousands of years of progress in what? In chemistry. Okay, now as you see, what should we know in the periodic table? First, we know that these elements are the components of everything around us. That means if you see yourself, your skin, your hair, the wall, the chair, the mobile that you use, everything around you is made of these elements. So that means on Earth now, all these elements on Earth that were discovered are now on this periodic table, that it was a great goal that was accumulated for thousands of years. Okay, now elements, as we know, are ordered or placed or organized in this periodic table based on the atomic mass. Okay, what is the atomic mass? Okay, now what do we know about atom? The atom, it has a small part inside it that is called nucleus. And inside the nucleus, there are protons and neutrons. And protons are positive and neutrons are what? Are neutral. So that means this is inside the nucleus. And around the nucleus, there are shells. There are what? Shells, like this. These shells now, electrons are there on these shells. So that means electrons are not in the nucleus, they are outside the nucleus, orbiting around the nucleus. So these electrons now, here for example, 2 electrons, then here 8 electrons. So that means the electrons are negative charges and they are around the nucleus in dynamic state. That means they are moving. Okay, these electrons now, and this is now the atom. Atom in general, any atom, it consists of a nucleus and inside it protons and neutrons. It consists of electrons. These electrons are rotating around the nucleus. Good. What is the difference between atom of one element and another element? How elements, as Dalton said, he said, atoms of the same element, they are the same, and of different elements, they are different. How they are different? Different in what then? Later we understand that they are different in exactly number of electrons and protons. So here now, in any atom, what should we know that? Number of protons or electrons, it is called what? Atomic number. Atomic number. So atomic number is number of protons or number of what? Or number of electrons. Is called what? Atomic number. Okay, what about atomic mass? Atomic mass. And this is one of the results of Rutherford. He said, as we said, there is a condensed part inside the atom. That means most of the mass of this atom is in the nucleus. So that means if we are calculating now the mass or how heavy an atom is, we're going to see that just we count number of protons and neutrons, since they represent nearly the total mass of the atom. So that means atomic mass is number of protons plus number of what? Of neutrons. This one is called as atomic mass. atomic mass. So you understand now what is atomic number, and you understand what is atomic mass. And atomic number is number of protons or number of electrons. And number of protons and number of electrons are equal in neutral atoms. So that means any atom, its electrons and protons, and for any element, they are the same number, and this one is atomic number. So atomic mass was the idea of Mendeleev. He said we order these elements on the periodic table based on atomic mass. Then mostly he said no, we reorder them based on the atomic number. That means number of protons or electrons, since they are what? The same, and this one is atomic number. Okay, now why do we put now these elements? And these ones, as we said, are all the elements that we see them in Earth. All these elements that were discovered, and they are the components of nearly everything around you, is composed of these elements that you see them now, about 118 elements, as you see till now. So that means, why do we put now hydrogen, the first one? Why did we put helium here, the second one, number 2? Why do we put lithium here, number 3? Again, this order is based on atomic number. Based on atomic what? Number. Okay. Why hydrogen is number 1? Because its atomic number is 1. What does it mean atomic number 1 is 1? That means it has 1 electron and 1 proton. So atomic number is either number of protons or number of electrons. Both of them, they are the same. So we deal with them like number of protons or number of electrons. This is for the atomic. So hydrogen is number 1 because it has atomic number 1. Okay, what about helium here? It's number 2, as you see, because it has 2 electrons or 2 protons. So that means it has 2 electrons, 2 protons. So that means its atomic number is 2. So we put it number 2 on the periodic table. And lithium, as you see, is number 3, and beryllium is number 4. Boron is 5, carbon is 6, 7, here nitrogen, here oxygen, here fluorine, here neon. So as you see, these elements now, in their places, now, they have taken thousands of years to be in this shape that we see it now. Thousands of years of discoveries to see it now as it is seen on this periodic table. So neon now, as you see, this is neon, as you see, and neon, it has 10 atomic numbers. So that means it has 10 electrons, 10 protons, so that we put it number 10 in the order. Okay, how now, the periodic table, how it goes? How do we order them? We order them when we move this way. We move from left to right on rows. So this is the first row, then we go here second row, then we move here third row. As you see, this is how we go in the periodic table in the order, from left to right, then down. So hydrogen is number 1, helium is number 2, lithium is number 3, beryllium is number 4, boron is 5, and so on, as you see these ones. As you see here, francium, for example, is 87. That means it's 87. That means it has 87 electrons, 87 protons. I hope that is clear. Okay, another question now. Why the periodic table take this shape? Why it is not square? Why it is not a rectangle? Why don't we put it just as a rectangle like this, and we divide it into 2 parts here, and we fill them inside it, and it becomes like a rectangle or like a square? Why? Okay, because scientists in general, they try to make this shape is similar of what is going inside the atom. Okay, what is going inside the atom? If we go now into the atom, this is the atom, and we said inside it is a nucleus, and around it what? Shells. 1, 2, 3, 4, many shells here. Then they found that the atom on the first shell here, the first shell can take only 2 electrons of any atom. Of any atom, the first shell can take only 2 electrons. Okay, what about the second shell? The second shell can take 8 electrons. This is, they found it by experiments. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, good. Then what's the result? Based on that, they found that the first shell takes 2 electrons. Say they put that the first, as you see, the first row only has 2 elements, which is hydrogen and helium. Based on what? Based on the first shell here, inside the atom, that it can take 2 electrons. So that means we put them here now, the first row, as only 2 elements, hydrogen and helium. And hydrogen, by the way, it has 1 electron on the first shell. So look, you know, just we are comparing, and you have to differentiate between the periodic table. When you are talking about periodic table, we are talking about all the elements, and we are talking about a specific atom of an element. So that means you have to differentiate that. Just you need to know that the shape of the periodic table is similar to the shells inside the atom. So that means the first period now, it represents the first shell, which is 2 electrons. Good. What about the second shell here? As you see, 8 electrons. As you see here now on the second row, there are exactly 8 elements. If you count them now, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, you're going to find them 8 elements, because they represent the second here shell that can be filled by 8 electrons. Okay, what about the third? It's the same time. Okay, now, but what we need to know now, that there are principles of energy levels. The atom has energy levels. Energy levels are called N. So N1, N2, N3, N4. So these ones now that we call them by N, it's called what? It's called the energy level. Okay, what is the maximum number of electrons on the energy level N? On the energy level what? N. You can use this formula to find it, 2n squared. So that means on the first level, on the first shell here, as you see, you put N1. 1 squared is going to be 1. 1 times 2, it's 2. So that means it's going to be 2. Okay, when N is 2, it's going to be 2 squared, 4. 4 times 2, you're going to find it, that's 8. Okay, and this one now, this one here, this rule it represents, keep it in mind, it represents the maximum number of electrons, the maximum. That means they can be less than that. So this one, it represents the maximum number of electrons an energy level can contain. And energy levels, as you see, it starts from N1. So that means it takes number 1, 2, 3, 4. There is no energy level called 0. There's no energy levels called negative or decimal. So that means energy levels, they take from 1, 2, 3, 4, 5, 6. And this is the maximum number of electrons that an energy level can take. It takes from 2n squared. Okay, now, if we are talking about now the first here, as you see, on the periodic table now, we need to understand also another thing. What we need to understand is this periodic table, okay, why don't we put them again in a rectangle? And the first row we put just two elements, and the second row we put 8 electrons, and that's it. Why just we divide it here into blocks, and one block is higher and one block is lower? Okay, we're gonna explain it now. Okay, this one now is block, and by the way, this block now is called block S, and this block, by the way, is called block what? P. And by the way, the helium, its places here. Keep that in mind, its places here. But we put it here since it has the same chemical properties of noble gases. But mainly it's in the S. So this one, so helium is in the S, it's not on the P. Okay, good. Then, what about this block? This block now is called block what? Block D. Okay, what about this block that is here? It is called block what? Block F. So that means how many blocks do we have in the periodic table? We have 4 blocks. And these 4 blocks, they are called subshells or sublevels. Subshells or sublevels. How? For example, now, if I'm going on the second shell, this one is the second shell, as we said, and it represents the second shell on the atom. Okay, this shell, it consists of subshells. What are these subshells? It has subshell that is S, and here it has subshell that is what? P. So that means the second energy level, the second shell or energy level, it consists of two subshells that are S and P. Okay, what about the third one? Okay, here now, if you see this one here, for example, this one here, as you see, you're gonna find it that it has S and D and P. S and D and P, and these ones are called what? Sublevels. So now the question can ask you, on the first shell, which is this shell, how many sublevels? Only one sublevel, which is S. That means there is no P here because the helium, we said it is here. So that means this one is called 1S, which is S only. What about the second energy level? How many subshells? We said we have two subshells. We have subshell here that is related to S, and you have here subshell that is related to what? To P. So there are what? Two subshells. Okay, now we go to number them, to number the blocks, S, P, how to number them, how to number these rows. Okay, and I hope you keep that in mind. It's very important in electronic configuration and in understanding the rows and columns, which is periods and columns. Okay. The first part here now, which is S, this one is called 1S. This one is 1S. Here, 2S, 3S, 4S, 5S. Here 6S, and here 7S. Okay, this is now related to S. So if I'm telling you now a question, where is potassium? In which block? Potassium is here, as you see, and it is in block what? S. And in which row? In which period? It is in the fourth period. Here now is written what? 4 on the S. So you understand now. Okay, good. What about P? This is P, as we said, and this is P. And P usually starts from 2P. So that means there is nothing called 1P. It starts from what? 2P. Then 3P, 4P, 5P, and here is 6P, and here is 7P. Good. Okay, so P starts from 2. Okay, what about D? And you're going to explain why. Okay, what about what? D. D here, it starts from 3D. So this one is 3D, and here 4D, 5D, 6D. So I need you to remember that S starts from 1. S starts from 1. P starts from 2, while D starts from what? From 3. Okay, what about F? What about block F? Block F that is here, as you see, it starts from 4F. 4F, then what? Then 5F. So keep it in order. S starts from 1. P starts from 2. D starts from 3. And F starts from what? From 4. So look here now. When D starts from 3, what's there for D? 3D. Here, as you see, we have 3D, 4D, 5D, 6D. So is there something called 7D? No. Is there something called 2D? No, because D, there are only 4D sublevels. 3D, 4D, 5D, 6D. What about F? F has only 4F and 5F. So that means only 2 sublevels for F. 4F and 5F. That means there is nothing called 3F. There is nothing called 6F. So F has only 4F and 5F. Okay, what about P? P starts from 2 to 7. So that means P has 2 and 3 and 4 and 5 and 6 and 7, but it has no 1P. Okay, what about S? As you see, S has 1 and 2 and 3 and 4 and 5 and 6 and 7 as well. Okay, these ones now, we gave them what number? Okay, what does that mean? Here now the number that is in front of the S, usually it represents the energy level. So energy level 3, that means it takes the 3S and the 3D and the 3P. This is the energy level. Okay, but you're gonna say, okay, why don't we put the 3D here? Why don't we take the 3D up so it goes to be on the same row of 3p and 3s. Why don't we push the 3d up so it goes to be the same row of 3s and 3p? I'm going to tell you that because now when electrons are, as you see, electrons are filled inside the atom, and electrons are filled based on the weakest level energy. So that means this one now is the weakest energy level, so it takes 2 electrons. Then it goes to this one, which is higher, then higher. So as you go, as you fill up and up and up and up for these shells, you go to higher energy level, higher energy level, higher energy level. So that means this here, this main shell, it has subshells, as we said. This shell, it has main shell, subshells. That means it has subshells inside it here. These subshells, as we said, they represent S and P and D and F. Okay. Now, when we order these ones, when we order the electrons inside the atom, what comes first? Again, here now, I'm going to erase these ones, but keep them in mind. Where is 1s to 7s, where is 2p to 7p, and where is 3d to 7d to 6d, and where is 4f to 5f. Okay, now. So here now, the first subshell that it will be filled inside the atom will be 1s. It's called what? 1s. Then what comes next? It comes this one, which is 2s. Then what comes next? This one we said it is what? 2p. Then what comes next? It comes here, 3s. Then what comes next? It comes next here, which is what? 3p. Then what comes next here? It comes 4s. Keep that in mind. Then what comes after 4s? It is 3d. That's why we put 3d after 4s. Because 4s now is, its energy level is less than the 3d. So that means electrons are filled in the 4s before the 3d. Before the 3d. That's why now we put the 3d is on the period of 4s. Because it gets, so that means the periodic table now is organized based on atomic number first. This is for related to numbers 1, 2, 3, 4, 5, 6. But it is shaped in this way, as you see, 1 up, 1 down, based on the electronic configuration. That means based on how electrons are filled on the subshells inside the atom. So that means, as you see here, 4s, then 3d. So that means when you fill the electrons inside the atom, 1s comes first. This is 1s. And 1s can be filled by 2 electrons. Then here, this part comes next, which is what? 2s can be filled by 2 electrons. That's why you put here 2 elements. Then here it comes what? 2p by how many electrons? 6 electrons. Then what comes next here, as you see, 3s by 2 electrons. Then it comes here 3p by also what? 6 electrons. Then what comes next here? 4s, and it takes 2 electrons here. Then what comes next here? 3d, that it takes what? 10 electrons. Then what comes here? 4p, that takes 6 electrons, and so on. So these ones now, the order now of the periodic table, when you go now from left to right, you go based on how electrons are filled in the same order in the atom. And I hope that is clear. But you understand now the maximum number of electrons in each energy level, how we calculate it, and we understand now how the order of them, how they go first. Which come, okay, the questions can come, for example, now, which one get electrons first, or electrons are filled first where? On 4s or on 3d. So that means if I know the order of the periodic table, that I'll know that 3d in the order of the periodic table, if I go from left to right down, I'll start by 4s, then I'll go to 3d. So that means 4s comes before 3d. I hope that is clear now, that we understand the periodic table is reshaped to be like now electrons are filled inside the atom. Okay, if we go deeper here, we're going to see that this is P. And P, it can be filled by how many electrons? By 6 electrons. These 6 electrons, each 2, they can be in one box that is called orbital. So electrons can be here in 3 orbitals. So P has 3 orbitals. Each 2 electrons, they make 1 orbital, while S has 1 orbital, 1 box. While D here now, it has, as you see, 10 electrons. They are in 5 boxes that are 5 orbitals. And these orbitals, by the way, these electrons, they come first here, the first electron. Then the second electron comes here. Then the third electron comes here. Then the fourth electron comes here. You see? Then the fifth electron comes here, and the sixth electron comes here. So that means electrons on the same sublevel, of the same energy sublevel, they get filled individually, singly, in each orbital first. When all the orbitals are full, then they come to the first orbital, then they start to be as 2. And they spin in opposite directions. So if you have 2 electrons in the same orbital, they spin opposite to each other. And this is what is called Hand's law. I hope that is clear now. We understand what are the blocks, and we understand what is the periodic table and how it is improved. And I understand the story of chemistry, how it moved to this way. And I understand what's there. S, what it's from 1 to 7, and D from 3, 4, 5, 6, and P from 2 to 7, and F, there are 4F and 5F, exactly. So if you forget these ones then in the periodic table, you need to remember that S comes from 1 to 7. So you write 1S, 2S, 3S, 4S, 5S, 6S, and here 7S. Then, what about P? We said P starts from 2 to 7, right? So you write it here, 2P, 3P, 4P, 5P, 6P, 7P. Okay, what comes next? As you see here, D. And D, we start from D, 3. So that means this is 3D, this is 3D, 4D, 5D, 6D. Is there something called 3? So 3, 4, 5, 6. Is there something called 7D? No. So this is for D. Okay, what about for F? As you see, F, we start from 4 to 5. So that means this is 4F and this is 5F. The order now, it goes exactly. It goes like this way. 1, then it goes this way, then it goes this way, as you see. It goes this way exactly. Then as you see here, 4S, then 3D, then this way. You see? It goes exactly what? This way. So if you forget the periodic table, you can redraw this one as I said, from 1S to 7S. Then P starts from the 2 to 7, the D just from 3 to 6, and the F. So that means, as you see here, if you forgot, you can say that this is SS, and this is just PES, and this is PES. Here it goes. Then here also, this is DPS. This is DPS, as you see, and this is FDPS, and this is FDP. So that means this one now, you can, if you forget, you remember these ones, which is you call them in Arabic like SS, bes, bes, dab, bes, dab, bes, fadab, bes, fadab. You can remember this way, or as I said, you can remember how the periodic table is drawn, and it's the same thing. If we take, for example, this one, just, you see, if you take just this one, you see, we start by 4D, then 5S, then 6S, then 5P, then 6. So that means if you go now to 4D, this is 4D. 4D, then it comes to what? Comes then 5P, then 5D, you see? Then 6S, then 6S here. Then you will go to 4F, then 4F. This is, by the way, this F now, it represents here, this one, lanthanides and actinides. As you see, the number here is 56. Then what is 57? 57 is lanthanides here, lanthanide. Then 58 till 71, then 72 comes here again, then you continue. So that means what is 1, 2, 3, 4, 5? That means on 6S, after 6S, as you see here, after 6S here, this is 6S. What comes after it? It comes 4F, exactly. This is now 6S, and it comes to it what? This one, which is what? 4F. It comes after. Then you move to 5D, which is this one, as you see, 5D. So that means just we put F here, but mainly F is here. F is here inside these stars. But if we plug them inside these stars, how will be the product table? It cannot be look like it's too wide, and it's not be then easy to be drawn. So in this case, just we give them stars, their places, and we draw them what? Down, but that one is their places. I hope you understand now how we order them. How we order first, which one we order, how we order them based on the energy level. Least energy level get filled by electrons first, and this is how they get filled. You remember these arrows, these white arrows that we draw them on the left, or you remember how the periodic table is shown, and here we remember. And in the next video, we're going to talk about electronic configuration. And electronic configuration, mainly, it is based on these ideas that we already explained here. Then in the third video, we're going to talk about periods and groups and elements, or the properties of some elements, and we're going to talk about trends of the periodic table. Thank you so much. See you then.